When can you see my screen? Okay. So I just also want to talk about how to run the trial. Okay. So you already have experience on running the trial. Some of you already did a couple of trials, so you might be knowing that. But I just want to tell you how to run the trial protocol first to get the desired results. Okay. So first, when you start the trial, we have to keep the feed redundant and permeate in the same vessel. Okay. Then you have to recirculate the product. Where is it? Yeah. So you can recirculate the product in the same vessel. Then you can start applying a different cross flow rate. Okay. So for example, you can start with 4 LMH or 4 LPM as a cross flow rate, 6 LPM, 7 LPM, something like that. And also parallelly, you can also increase the different TMP, transmembrane pressure, and start measuring the flow of the permeate to get the consistent average flux. Okay. So this process is called TMP excursion curve, where this really helps us to optimize the process while running the trial. Okay. So first we need to set up the KR2A system in a same way. You can connect all the reservoirs, hollow fiber or cassettes. You connect the feed line, connect the pump, everything. Then you start pumping the uh, liquid into the main pump on a recirculation mode and monitoring the pressures of feed, retentate, and permeate, and automatic back pressure control valve used to control the TMP. We can also use the screw clamp to maintain the back pressure. Okay. And also you can monitor the permeate consistently continuously after applying the back pressure or TMP throughout the process. So you can log on to the system on a manual mode like this. I'll share this protocol with you. Probably you can use this protocol to run the process. And before we start the process, prepare the filter before you use it. Flush the filter, sanitize it if required, then do a buffer equilibration, then measure the NWP, check the integrity, and drain all the stuff. Then connect tear the pressure transducers, direct the retentate permeate into the main reservoir. Then fill the reservoir with the target material, and then start running the process with a different cross flow rate or different shear rate. So we can start with the 2000 as a minimum shear rate when you use hollow fiber. Then you can move to 4000. Then you can also go up to 6000 as a three different cross flow rate. With the flash sheet, you can start with 4 LPM, 6 LPM, and also 8 LPM. Then when it comes to this TMP set points, you can set the TMP with the four set points. Like, usually, we keep zero point 0.5 TMP, 1 TMP, 1.5 TMP, and also 2 TMP, four different set points. And until we until it reaches the flux reaches to plateau, then we start measuring the permeate flow rate with a different cross flow rate at four different set points. Okay. Then when you go for the flux excursion, you can set up the after excursion. You can check the flux of every after stabilizing after 5 minutes. Then you can measure the complete value uh, of the average flux or the flux. Then finally you can make a graph like this. So as you can see here, you have three different data points, like the different time, different shear rate, and different flux, and also TMP. For example, at 8,000 in a second, every 1 minute interval, how much volume you're collecting, how much flux you are getting on a different TMP. So if you see the TMP condition, like 1.5, 2.9, 5, 9.8, and 15 PSI, with a one set of TMP, and the next would be like 2 liter per minute as a flow rate. In terms of shear rate is 6,000 a second. Again, we are working with the same TMP condition, and again it is repeated with the 4,000 in the second as well. So we are checking from 35 ml per minute as a maximum, 27 ml per minute as medium, and 18 ml per minute as a lower side. Then we plot the graph with a different shear rate and different cross flow rate. Then we find out the actual knee point to select as an optimum TMP and optimum shear rate. So that would be the value which is used to go for a scale up. And that is a point where we need to stop and start recording all the information. Then finally you can make this graph to optimize to give the inputs for the optimum conditions for the scale up. So this is how we perform the trial to optimize the process with a different TMP, with a different shear rate or cross flow rate. So any question on the protocol? Anyway, I'll share this with you. Maybe you can go through this. And if you have any question, probably, you can come back to me and I can answer your question.
Yeah, thank you. I think with for trial running with Dr. C team, could you arrange time to work with Earth on site?
Yeah. So, we will do the same optimization with CQ
Yeah.
for the process. So
mm,
we will find out the right cross flow condition and also the TMP condition to run the process and also scale up
yeah,
the process. Yeah.
yeah.
Okay.
Because I see Dr. CE team they have many experience to running with other TFF system from Citiva, from
Mm-hmm.
from
Certain
some,
yes.
yeah,
Okay.
citrus. So I would like the trial running for 1 or 2 batch with
Mhm.
customer will be successful. Yeah, for beginning relationship.
Okay.
Mm.
Yeah. So yeah, definitely probably end of the February, maybe I can also join for the
Yeah.
trial. Okay. So I can also show the team to how to run the trial,
Mm.
and
Yeah.
also we can train the customer team as well to how to run the process and also how to run the uh, optimization process.
Yeah. 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 It's great.
Mm.
As the plan to work with customer, the first for TFF they will run the trial in Vietnam with TFF system in Vietnam.
Mm.
For Excel system,
Mhm.
yeah, they would like to know how efficient of this system, and I already have one option that we can arrange the training or the any trial running in the any lab
Mhm.
in India to run in Excel or in Singapore.
Yeah, so we use the same system to run the
Yeah,
trial in India and Singapore everywhere.
yeah, yeah.
Okay.
Mm.
Uh,
No,
uh,
no. I mean that Excel system.
Excel system,
Yeah,
the ATF.
yeah. ATF.
Okay, okay. Yeah, so yeah, we can also plan the Excel ATF training also.
Mm.
Okay.
Or
Uh,
or or any run demo with customer sample in any demo in Singapore or India.
yeah, so we have 2, 3 systems in India to run the demo.
Yeah, good.
Yeah, yeah, yeah,
Yeah,
yeah, yeah.
yeah.
So
We can.
we
Yeah.
always run the demo for to run the purification process or CFB or RS process. We always use
Mm.
the Excel ATF.
Mm.
Okay.
Yeah,
So
yeah.
if the customer wants to run
Mm.
the Excel ATF, maybe we can organize the trial as well.
Yeah, it's good.
Yeah.
Yeah, yeah.
Yeah. Yeah.
It's
So
good.
that also we can discuss with customer. If they agree, probably we can also organize one demo run in their site as well.
Yeah, yeah. Okay.
Yeah.
After after running DFF demo in Vietnam.
Sure, 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 sure.
Yeah.
Yeah.
So now I will confirm with customers some question about you already recommend to check which part code of flat cassette to running for trial in Vietnam
Mhm.
first.
Okay. Okay.
Yeah.
Yeah.
After that, I will place order this cassette to Vietnam, and we can begin to trial end of February.
Sure, sure. So let me know the volume and what is the concentration they're looking for, and also what is the diaph filtration they're looking for. Then based on that, we can run the trial with the customer. We
Yeah.
can we can show that it is working for them. to get the better result to order the system or the
Yeah, yeah.
cassette. Yeah,
Okay.
yeah,
Okay. Thank you very much. Okay.
yeah.
Mm,
I'll
yeah.
share this. I'll share the slides and also the protocol with you. Probably you can just have a. You can go through, and if you have any questions, or if your team have any questions, they can come back to me.
Yeah. Thank you.
Okay.
Yeah. Thank you very much.
Okay. And thank you very much. Thank
Okay.
you, everyone.
Yeah.
Okay.
Okay. Thank you very much for your time.
Looking forward to see you soon.
Yeah. Thank you very much. See
Okay.
you soon.
Yeah. Thank you. Yeah, see you
Yeah.
soon.